As we know, our population is rapidly aging. Dementia is an increasingly big problem. Everybody knows someone who's been affected by this condition.
We're not going to be able to cure Alzheimer's disease and related conditions in the very near future. And I think TARC has been instrumental in bringing a bunch of these new, bright people into the field to kickstart their funding such that they become eligible then for funding at the federal level.
So they're really just getting their feet under them. They take the TARC money and put it to great use, and then continue to make an application for things at the federal level. Much, much more generous and larger dollar values are awarded.
It can be very difficult for somebody starting their research career to get enough funding to put their first set of ideas together, do some experiments, get some data that will allow them to go to the next level and obtain some sort of research grant.
Bringing along young investigators and people who want to stay in Texas, to me, is like one of the most important things TARC is doing. I was fortunate to get one of the postdoctoral fellowship training grants and recruited a great early postdoc, and she has become an investigator, gotten her own grants.
It is not beyond the realm of possibility that he or she can turn that initial $300,000 or $400,000 into several million. And we are seeing today in TARC, in the real world, it is happening.
So if Texas has ways of using the seed money to cleverly coordinate these efforts, I think that it bodes well for the future.
Please welcome back to the stage Dr. Rodrigo Morales.
All right. So, welcome to the second part of this Data Blitz session. Now we will have 8 presentations. Oops. And we will start with Dr. Charles White from UT Southwestern.
I'd like to thank Dr. Cullum, my long-term friend and colleague at Southwestern, for pointing out that all of the Data Blitz talks today are being given by junior investigators in the organization. And actually, I'm pitch hitting today for one of my junior colleagues, Satwik Rajaram, who is certainly the scientific force behind this presentation and had a faculty research day today in his department. So the topic today is deep learning reveals disease-specific signatures of white matter pathology and tauopathies. We hear a lot about tauopathies, and we usually think about the cortical lesions that are involved in deposition of tau in Alzheimer's disease and other tauopathic disorders. But we decided to look at what is clearly going on in some of these entities, namely a significant amount of pathology in the subjacent white matter. So we selected 3 entities: Alzheimer's disease, progressive supranuclear palsy, and cortical basal degeneration. These are all characterized by deposition of tau primarily in gray matter, but also to some extent in white matter. For those who are not familiar with PSP and CBD, these are disorders that are variably classified as movement disorders or as frontotemporal dementias, but that reflects the fact that they have both motor and cognitive features in many cases. In any case, in all of these diseases, there's both gray and white matter pathology. The canonical lesions that we use to diagnose tauopathies are usually focused on the things that we see in the gray matter. And so white matter has received a lot less attention, although white matter is certainly important in neurodegenerative disease. In fact, most of the connections that extend between areas of cortex or between cortex and subcortical areas pass through the white matter. So if one is inclined to think about degenerative diseases as a connection disorder, and that's certainly one hypothesis about its pathogenesis and clinical expression, then certainly white matter has to be an area that's involved. So, so the team investigating this entity include Satwik, who is a computational biologist, responsible in this project for most of the conceptual design and the computational analyses. Screen over there keeps going black, but I guess it's up here. Tony Vega was a joint fellow between Sotwick's lab and Mark Diamond's lab, and he did many of the computational analyses in association with Sotwick. Roddy Shahedzi was a neuropathology fellow who was involved in case selection and in performing aggregate annotations for training the deep learning algorithms. Vipul is a data scientist that worked with Sotwick, and Mark Diamond and I were the cheerleaders on the project. So, we took several steps to the approach here. Step one was obtaining the tau stains on about 20 cases each of AD, PSP, and CBD. And here are illustrated some of the cardinal features of these disorders. On the right side of each panel are the classic cortical lesions that we usually are using for making diagnoses of these tauopathies. And on the left is the presence of white matter staining, which, as I'll point out, is far less typified than the cortical lesions. In AD, the cortical lesions include neurofibrillary tangles and senile plaques, those things that we all can recite in our sleep now. PSP is characterized by neurofibrillary tangles, as in AD, but it also is characterized by the presence of a unique type of tau deposition in astrocytes, and these have become have acquired the name tufted astrocytes. Tufted astrocytes are virtually pathognomonic for PSP. And then finally, cortical basal degeneration at the bottom is characterized by the presence of glial plaques, plaques that look on tau stains very much like senile plaques of Alzheimer's disease, except that the radiating processes at their periphery are composed of glial processes rather than axons and dendrites as they are in Alzheimer's disease. So the first thing that we had to do is separate the gray and white matter, and this sounds like a simple task, but this is a very tedious thing to have to do manually. So we trained a deep learning algorithm to be able to differentiate gray from white matter. And that was fairly easy for a computer to do in these entities because they all have some difference in density and nature of staining of tau-positive lesions between the gray and white matter. So it was cheating a little bit because we took advantage of the nature of the deposition between gray and white matter in these entities, although our future plan is to train a classifier that works strictly on cytologic and nuclear features of normal tissue elements so that we can apply this to other entities for differentiating gray and white matter. So the next thing we did was at panel C at the top, and that was to take half of the cases of each of our groups of AD, PSP, and CBD, and for the neuropathologists, namely Roddy and myself, to sit down and at a computer click on each individual tauopathic aggregate within the white matter. And that was to train the computer what to look for in the way of aggregates in any of these diseases. So all we did was identify each single aggregate as a disease-associated subtype. And then we used that to train the computer to be able to differentiate the three subgroups. And then we fed it cases of AD, PSP, and CBD that it had not seen before. And with greater than 90% accuracy, it was able to cause each of the three disorders to be classified into their various subtypes. And again, this was based on the fact that it was recognizing differences in aggregates that we had trained it to look for. The last component of the project, which I think is the most interesting, is that we fed the same group of training cases to to the computer. And in this case, we said, differentiate between gray and white matter, and then find things that characterize and distinguish these three disease classes, which it did with, again, 90% accuracy. It was able to differentiate AD, PSP, and CBD using cortex, or with equal accuracy, white matter lesions. And so this summarizes those findings. Distinguished gray and white matter with almost 90% accuracy. Strong correlation between gray and white matter tau burden, even though the lesions were different. And it differentiated these three entities with over 90% accuracy using either gray matter or white matter. So, to summarize, white matter tau pathology is informative, it's disease specific, and it's linked to gray matter pathology. Machine learning has the potential to reveal latent information in histologic images not readily apparent to human observers, meaning if in that last panel I had given 10 each of those cases to pathologists and said, only look at the white matter and tell me which of these is AD, which is PSP and CBD, we would not have reached 90% accuracy, guaranteed. And then finally, recognizing that there is this prototypical disease-specific pathology in the white matter may lend understanding to our understanding of disease mechanisms, pathophysiology, and hopefully help to develop specific therapies as these come down the pike. Thank you very much.
Hi, good morning. My name is Felix Moruno. I am assistant professor at the McGovern Medical School at UT Health Houston. Thank TARC for funding my research. My research is focused on understanding the mechanism that govern the brain aging, particularly the brain vasculature. I do have expertise in neurodegeneration, autophagy, and cell senescence. The major goal of this specific project is to understand the molecular mechanism of endothelial senescence and how this contributes to vascular dementia with aging. So my team is formed by Silu Monga, Said Rahman, and a former member, Brian Knott, and we are part of the Brains Lab, led by Dr. Luis Macalot, chair of the Department of Neurology in the same institution. Endothelial senescence has been proposed that negatively affects the brain vasculature and contributes to brain aging. So cell senescence basically is a mechanism characterized by the stop of replication, enlargement of the nuclei, accumulation of lipids, lysosomes in the cytoplasm, and the secretion of pro-inflammatory molecules that negatively affect neighboring cells and also cells in other tissues. Endothelial senescence impacts the integrity of the brain vasculature, and that leads to an infiltration of immune cells into the brain, exacerbate the inflammatory response, reduce cerebral blood flow, and all these increase the risk for neurovascular problems. So it has been proposed that DNA damage is a major cause of senescence. All cells have DNA repair pathways, but these pathways are less efficient with aging. So age cells accumulate DNA damage. And this DNA damage triggers the expression of pro-inflammatory molecules and goes into the state of senescence. So identifying the factors that regulate DNA repair is a strategy to mitigate or prevent senescence, and particularly in the brain vasculature. One of these factors is HOF1. HOF1 is a transcription factor that regulates many genes involved in different pathways, but importantly, it regulates the expression of different genes involved in DNA repair pathways. And also the expression of HOF1 has been associated with the inhibition of senescence. Given that DNA repair pathways are reduced or they are downregulated with aging, we wondered if HOF1 that regulates DNA repair is also downregulated in the brain vasculature of aged mice. So for this, we isolated microvessels fraction from young and aged mice. These fractions were fixed and stained with endothelial marker, and also with the phosphorylated form of HF1. This phosphorylated form indicates the transcriptional activity of this factor. So after quantification, we observed that the microvessel from aged mice have reduced HF1 phosphorylation, indicating that the activity of this factor is reduced with aging in the brain vasculature of mice. So if this factor is downregulated in the brain vasculature of mice, we wondered if upregulating, if overexpressing this factor, specifically in the brain vasculature, can affect or can improve the brain function in aged mice. So for this, we use an adenovirus construct that specifically targets the brain vasculature. As you see in this figure, the vector that expresses GFP colocalized with the blood vessels stained with tomatolectin. So we designed two constructs, a control construct and another construct coding for HF1. And these were injected into 20-month-old mice, and 2 months later, they were tested for different behaviors. This graph corresponds to open field. We didn't observe any significant changes between the control age and aged mice expression HF1 in brain vasculature. So the expression of HF1 doesn't affect the motor skills. But we do observe significant changes in the white maze, and we measure the percentage of alternation. That is an estimation of the spatial memory. So look at the HF1 aged mice have significant increase of percentage of alternation compared to the control aged mice. Curiously, we didn't observe any changes in the novel object recognition test for preference of index, but we do observe a significant increase of the percentage of time inactive in the fair conditioning test that indicates the conditioning memory. So the expression of HF1 in the brain vasculature specifically improves spatial memory and conditioning memory in aged mice. So to better understand the mechanism by which HF1 is beneficial for the brain function, we first, as a first approach, we use an in vitro model of endothelial cells. We previously demonstrated that this model recapitulates features observed in the vasculature of mice. For example, cells isolated from aged mice recapitulate senescence-associated phenotype that has been observed in the brain vasculature of aged mice. So we isolated endothelial cells cultured from 4 months old and 20 months old mice. These cells were fixed and stained. I'm sorry. How can I go back? Yeah. They were fixed and stained with the phosphorylated form of HF1 and a DNA damage marker. So observe that the 8 cells have reduced phosphorylated form of HF1 that recapitulates what we have shown in the brain vessels, and also an increase of DNA damage. So next, if DNA damage is increased in 8 cells, maybe upregulating HF1 can reduce this feature. So endothelial cells from aged mice were transfected with a controlled plasmid and a plasmid coding for HF1, and also transfected with a plasmid coding for GFP to visualize the cells. And these cells were fixed and stained again with the DNA damage marker. Observe that the cells that express HF1 doesn't have the signal for DNA damage. So the expression of HF1 in 8 cells reduced DNA damage compared to the control cells. So to identify the downstream gene targets of HF1, we transfected 8 cells with a control plasmid and the HF1 plasmid, and we analyzed the transcriptome by RNA sequencing and identified that the biological process involving immunity are upregulating with HF1. In this volcano plot, we identify ACOD1 as a gene that is mostly upregulated with expression of HF1 in 8 cells. So ACOD1 is a gene that codes for the enzyme acotinate carboxylase involved in the Krebs cycle. This molecule has immunoregulatory properties, and it has been shown that prevent oxidative stress in vivo and in vitro models. So we wondered if treating 8 cells with itaconate can prevent DNA damage as well. So we use a derivative form of itaconate that is more permeable for cells. And we treat it for 1 hour and then treat it with hydrogen peroxide overnight to induce oxidative stress. And we observed that the treatment with itaconate reduced DNA damage and also prevent the cell death associated with hydrogen peroxide. So as summary, we have used primary culture of cerebral endothelial cells. We have used molecular target to target specifically the brain vasculature, and we have identified ECOD1 as a downstream gene target of each of one. As a medical perspective, targeting brain cells is always challenging because they limited access to the brain, but targeting the brain vasculature maybe is a more feasible approach to mitigate cognitive impairment with aging. Thank you very much.
Hi, my name is Jonathan Singer. I'm from Texas Tech University Health Science Center and Garrison Institute on Aging, and I'm really excited to be here today and talk about our pilot study and provide some preliminary results. So we are investigating the relationship between stress and neurocognitive functioning in persons with dementia and their caregivers. So as we probably all know, in Texas, there's a huge increase in individuals with Alzheimer's as well as other types of dementia. But one thing that's really problematic is the lack of geriatricians, neuropsychologists, neurologists, especially in areas like Lubbock as well as the rural areas. And so we know that over the next year, next 5 years, next 10 years, we're going to have this huge increase, but that our rates of neurologists, neuropsychologists, and geriatricians is not increasing as well. And so what we need to do is to create interventions that can be administered by individuals who are not neurologists or neuropsychologists. So access to care is really difficult. So Lubbock is all the way in West Texas, and we serve a large rural area there. And most of these rural areas don't even have primary care physicians. And that's problematic through the whole state of Texas, but as well West Texas. So as we age, there's significant cognitive decline, starting sometimes as early as 45, but usually around the age of 65. And we know that normal aging declines affect memory or processing speed. And we know that things that make it worse or exacerbate it are stress, medical conditions, and psychosocial factors. But one thing that's been coming out in the literature lately is being a caregiver can exacerbate it. So one of my students actually made this. I'm not this creative, so follow me through this. But so as we're caregiving, as people are caregiving for their loved one with dementia, they have a lot of roles and responsibilities. And we know that these roles and responsibility lead to problems with psychological dysfunction, decreased physical health, and decreased social support. And now we know that it leads to decreased cognitive functioning in some caregivers. And we know that as caregivers decrease in their cognitive functioning, it makes their roles and responsibility much harder, which leads to this cyclical cycle that's really problematic. So the other thing we know is that most people, especially in these smaller towns like Lubbock or in the rural areas, are living at home much longer because there aren't as many care facilities, and people want to stay at home. So they're with the person who's caring with them all the time. And so one of the things that we're really interested in is looking at dyadic models, how my stress affects my partner's stress. And there's a ton of literature from Hoda Badar in the cancer literature as well as other researchers. But what we're interested is if we can predict stress in the person with Alzheimer's can affect neurocognitive functioning in the caregiver and vice versa, we have a lot more intervention targets if we can look at the dyad rather than the individual alone. So that's what we're trying to do, is to really look at, is there this interdependence between the individual, the caregiver, and the person with dementia? So what we've done is we created a study called Creative Minds. And it's a very simple study it's a 12-week respite intervention study. So what happens is the caregiver drops off the person with dementia to Garrison, and we have a big group room, and it's between 5 and 8 individuals, and it meets 3 hours a week. And they get to do different activities, and I'm going to talk about these activities a little bit more, but these activities are built to try to get at different aspects of neurocognitive functioning. But the other part is that the person, the caregiver, now has 3 hours of respite where they can do whatever they want. So they can go to the grocery store if they're not able to. With the person with dementia, they're able to go meet with friends with coffee and so on. So at the beginning of the intervention, we give a full neurocognitive evaluation as well as psychosocial measures to the caregiver, but then we give that same neurocognitive evaluation to the person with dementia. So when the person comes in with dementia, they do a lot of different activities, and one of the things that our literature is really is problematic is that we use screeners such as MMSE and MoCA to say a lot about neurocognitive functioning, but there are different aspects of neurocognitive functioning, so we're trying to target everything from overall neurocognitive functioning to visual spatial functioning to executive functioning and to verbal fluency. So you can see here that we have sensory activities, we have fine motor activities, physical activities, and visual auditory stimulation activities as well that we do that get at these different aspects rather than just one activity that gets at one part of neurocognitive functioning. So we're trying to look at all of it. So again, these are preliminary results, so we're not saying that we cured dementia or that we've made this huge impact yet, but we're saying that these are going in the right direction. So this recreational intervention is 12 weeks long, and so you can see here on the left, this first one, I don't know how to make the sensor work, but you can see that overall neurocognitive functioning with these 10 dyads, we actually saw most people actually improved very little. Again, not statistically significant, or not statistically, we're not looking at that, we're just looking at which way it's going. And then we saw 2 people stay the same and 2 people got worse. So we're seeing that it's going in the right direction over a few months. And overall, and then executive functioning went up just a little bit. Again, we're not saying that we're making people's cognitive functioning better, but that it's going in the direction that we want and it's not decreasing. So then looking at the recreational effects on caregiving. So this is that 3 hours of respite a week. What we saw on the left, you can see here, is that stress over these 12 weeks significantly decreased. And then here with anxiety, we saw the same thing. And then overall cognitive functioning, this is using the R-band, so just looking at overall neurocognitive functioning, we saw that the average went from 108 all the way up to about 113.5. And what we think the mechanism of why we might be seeing this is we just have reduced stress and anxiety. So the mechanism is that caregivers are stressed, they're anxious, they have all these responsibilities on their plate, and so it's leading to worse neurocognitive functioning. So providing just 3 hours of respite a week shows that it's going in the right direction. Now, to my next kind of hypothesis, and this is the kind of novel part of it, is we wanted to look how these dyads change over these 12 weeks. What is the interdependence? And what we found is 7 of the 8 dyads, we had some missing data of the 10 dyads, but 7 of the 8 dyads move together, meaning that we don't care if they go up or down necessarily, but do they move together? So if a caregiver's neurocognitive functioning over the 12 weeks increased, so did their loved one with dementia. And vice versa. If they decreased their neurocognitive functioning, individuals with dementia, the caregiver did as well. So we saw this interdependence between them, which is really interesting. Then we wanted to look at this model, that dyadic model I showed at the beginning, looking at the interdependence between stress and neurocognitive functioning. And what we found, again, that we don't care if stress goes, we want stress to decrease, but in this case, we just want to see if they move together. When stress went up, neurocognitive functioning of the person with dementia decreased and vice versa in 7 of the 9 dyads. So we saw this interdependence actually happening. So this provides just preliminary evidence that dyadic interventions are really important and can be run by graduate students, by undergraduate students, and they're inexpensive, as well as that we're moving the needle in the right direction with the small sample, but bigger samples need to be done in the future, as well as in rural areas. So I want to acknowledge participants in the study, my lab members, funding agencies, and some of my mentors. So thank you so much for listening.
Thank you very much. So next speaker is Miss Alisa Aguirre from UT Austin.
want me to do it? Hello, everybody. My name is Alyssa Aguirre. I'm a clinical social worker, clinician researcher right here at the University of Texas here in Austin. I'm the Assistant Director of Dementia Care Transformation in the Department of Neurology and Assistant Professor of Practice at the Steve Hicks School of Social Work. I've had the pleasure of working on TARC research studies now for the last 7 years, and it's been so exciting to be a part of those projects, and I just want to thank the TARC committee for all of your support. I'd like to express my gratitude to our wonderful research team, several of whom are here today. One of the strengths of our research project was that we had a variety of backgrounds and expertise in the area of informatics, machine learning experts, pharmacy, neuropsychology, and social work, and that greatly contributed to the success of this project. In fact, our research team was across 3 different continents at the time of this project. Have any of you ever had the experience where your research project didn't go exactly as planned? Well, that's pretty much what happened to us. We were working on an NIH R56 funded project to develop an app that would enable us to give tailored information to dementia caregivers based on their health information wants and needs. Unfortunately for us, ChatGPT beat us to the punch. And so in the words of my 5-year-old daughter, we had to use our power of flexibility and pivot a little bit. So getting to our research question. One of our researchers, Dr. Bo Shi, found a really interesting article in JAMA where a cardiologist looked at 26 commonly asked questions that his cardiology patients asked him every day. He entered those questions into ChatGPT and used a scale of appropriate or inappropriate responses. They found that 84% of the responses were appropriate. Building on that, 2 other teams looked at areas of cirrhosis and bariatric surgery. They looked at common, simple questions like, what are the symptoms of cirrhosis and what are the risks of bariatric surgery? They used a 4-point scale looking at, was the response comprehensive? Was it accurate? Was it mixed or completely inaccurate? So that led us to our research question. Does ChatGPT have high-quality responses to real-world questions asked by dementia caregivers? So how do we do that? We went to the internet. We looked at the social media site Reddit, and we looked at 3 specific categories in the areas of memory loss and confusion, as defined by confusion about the place that they're in or the person that they're with, aggression, and driving. We chose those 3 categories specifically because those are commonly asked questions in clinical encounters, and they all have an element of safety, and we wanted to see how ChatGPT would do with those 3 elements. Our machine learning experts found 4 seed posts in each of these categories and found other posts in these categories. Our final study sample had a total of 60 posts with 20 in each category. Those posts were vetted by Dr. Robin Hilsbeck and myself to look to see if the posts were indeed in that category and if the poster disclosed a dementia diagnosis. We took those posts and put them into ChatGPT, and we used a 5-point rating scale to see if they had high-quality responses in ChatGPT. One of the neat things is that our raters, we had 3 clinical raters from pharmacy, neuropsychology, and social work. So we brought diverse perspectives into evaluating the ChatGPT responses. This was the scale that we used. It was originally used by Hertz and team in 2012, and it was just the first 4 characteristics, looking at the cognitive complexity of questions used for healthcare certification exams. It was derived from the language of Bloom's taxonomy code, which is commonly used in education, as many of you know. We added the 5th characteristic of comprehensiveness. So essentially what we were looking for in the ChatGPT responses was, first of all, did ChatGPT have anything that was inaccurate or false? Did ChatGPT accurately interpret the poster's main need or question? Did ChatGPT provide information that was tangible that the caregiver could use in the moment, action strategies they could use to solve their problem? Did the response contain follow-up recommendations that were appropriate? And finally, was the response robust and thorough? We were all surprised that, in fact, ChatGPT did have high-quality responses. Of all the 60 posts that we looked at, none of the posts scored a 0, a 1, or a 2. 13 posts scored a 3, and 78% of them scored a 4 or a 5. If you look at the table on the right, we wanted to really dig in and see what were the strengths of ChatGPT and what were the weaknesses. 93% of the posts had accurate information, And 90% of the posts gave information that the caregiver could use in the moment, and 96% of the posts had accurate follow-up recommendations, such as a referral to a support group or an elder law attorney. The areas that it struggled with the most were in the area of interpretation. 78% of the posts, ChatGPT correctly interpreted the poster's main need, and only 63% of the posts were rated as comprehensive by our team. So let's dive into that a little bit more. In the area of interpretation, the ChatGPT response would lose the point if it made a suggestion that the poster had already tried. For instance, if the poster had said they brought their parent in for a medical evaluation to look at a new symptom, and then the ChatGPT response would say, bring your parent in for a medical evaluation, ChatGPT would lose the point for interpretation. Sometimes ChatGPT would miss the subtleties that we would understand as humans. For example, one of the posts talked about moving the relative into a home. We all understand that that usually means a residential care facility. However, ChatGPT did not pick up on that nuance and thought that it was talking about a single-family home. In the area of comprehensiveness, ChatGPT struggled sometimes to understand and think about the future possibilities that the poster might need. So in the driving category, for example, the poster would talk about, or the ChatGPT response would say, you should have your parents' driving evaluated. However, it wouldn't make suggestions for what to do if the person refused to get their driving tested, which we know happens all of the time, such as disabling the car battery or moving the car to another person's house. I thought it would be really fun to look at one of the posts. I selected this post specifically because it was short enough to fit on the slide. When I talk about post complexity, there was a range from 58 words to 550 words. So this really went beyond just what's the difference between dementia and Alzheimer's disease. These were really complex questions. The average post had about 250 words in it. This poster was in the area of aggression. As you can see, they disclosed a diagnosis of dementia. They talked about extreme outbursts, getting violent, and refusing to go to a home. In the ChatGPT response, all three of our raters scored this a 3 out of 5. The ChatGPT lost points for this response because they didn't give tangible action strategies that the poster could use in the moment. When they were having an extreme outburst, what kinds of things could they do, such as using de-escalation strategies, joining and validation strategies? And then in the area of comprehensiveness, we felt like given the potential for violence and needing a safety plan, the ChatGPT response really should have had more information about developing a safety plan, calling 911, having a safe place in your house to go to. So for that reason, it lost the point for comprehensiveness. So overall, our pilot study suggests the potential for ChatGPT to provide high-quality information to support the caregiver needs of dementia caregivers, and especially in tandem with licensed healthcare professionals. Future studies should look at the receptiveness of family caregivers and even using ChatGPT and evaluating the usefulness of ChatGPT information from the perspective of family caregivers, as well as looking at other social media websites. And if you're interested in some of the research that I referenced, you can find it at the last slide. Thank you so much for your time.
So now, from Baylor College of Medicine, we will have Dr. Molly Horstman.
Good morning. My name is Molly Horstman. I'm a hospitalist and health services researcher at Baylor College of Medicine and the Michael E. DeBakey VA Medical Center. And this morning, I'm going to be presenting some work from my VA and IA Career Development Award in Alzheimer's disease and related dementias. My primary mentors for this award are Dr. Mark Kunick and Dr. Alan Stevens at Baylor College of Medicine and Baylor Scott and White Health, respectively. So we know that hospitalization is very common in adults with dementia, and you can all take my word for it. Most of you probably know this, but hospitals are not designed for older adults, right? So when an older adult is admitted to the hospital, we wake them up in the middle of the night to get their vital signs. We keep them captive in their beds with bed alarms. And so it's really no surprise that when adults with dementia leave the hospital, they often face new or worsening medical conditions, worsening functional impairment, and worsening cognition. And the literature tells us that, unfortunately, for many of these older adults, that they don't actually regain everything that's lost in the hospital. And so the hospitalization is a tipping point where after that hospitalization, these adults may never be able to go back to the way that they were and forever need new supports and services from their family and friends. And we rely on caregivers a lot to support adults with dementia after hospitalization. And unfortunately, once again, decades of research tells us that in the hospital, as physicians and social workers and everybody else, we don't do a really great job. And part of my CDA, we have completed semi-structured interviews with caregivers and with health professionals to try to figure out what do caregivers need, resources and information during care transitions. And one of the striking things about these interviews is how little we talk about dementia in the hospital. And in particular, talking about the realities of what happens to adults with dementia when they are hospitalized. And I think there are a lot of potential reasons why this is the case. But I think one of the challenges really is workforce preparedness, right? The workforce is just not prepared to care for these adults in the hospital. Because across the country, adults with dementia are cared for by generalists, like myself, who have almost no formal training in geriatrics or dementia care. And despite kind of conversations for decades that we need more geriatrics training for health professionals, I really don't see this changing anytime soon. And so we need to think about new models of care for supporting caregivers, because we can't just tell providers that they need to do a better job. So my approach has been to build on the robust research being done in caregiver support in community and outpatient settings by adapting Game Plan for Care to the hospital context. For those of you that were at the TARC meeting last year, you may remember their presentation on Game Plan for Care. It's a web-based dementia caregiver support program that was developed by Dr. Alan Stevens and his colleagues. Game Plan for Care is based on REACH-2, and as some of you may know, REACH-2 is a multi-component intervention that provides tailored education, support, and skills training to caregivers of adults with dementia. And decades of research have actually established the efficacy and effectiveness of this intervention, and it is one of only 2 dementia care interventions that were recommended by the National Academy of Medicine as having sufficient evidence to support widespread adaptation and adoption. So the question and kind of challenge that we faced was really not, is caregiver support going to be meaningful or helpful to caregivers, but how could we deliver this community-based intervention in the context of a hospital setting? So the first part of my career development award has really focused on the adaptation process of Game Plan for Care for the context of a VA hospital and care transitions. In implementation science, adaptation is a rigorous process where intentional modifications are made to an evidence-informed intervention to achieve a better fit between the intervention and a context. And so as part of the adaptation process, we use adaptation frameworks to fully describe the purpose and rationale for any modifications that we make. And so to guide our adaptation of Game Plan for Care, we've used data from semi-structured interviews, the published literature, as well as feedback from a stakeholder panel and our expert consultants. So when developing this project, there were several contextual factors that we knew we needed to account for. So one of those being the VA. Many of you may know that the VA offers a wealth of services to veterans with dementia, but the caregivers themselves are not veterans, and they often don't understand how the VA functions. It's kind of a world unto itself. The second thing is that care transitions literature really demonstrates that if we're going to impact post-discharge outcomes, we really need to start interventions in the hospital. And we knew that was going to be a challenge. Hospitalizations usually only last a few days, and caregivers are busy people. They're not always able to be present in the hospital. The other thing that we knew was going to be a challenge was that a lot of these interventions for caregiver support, as I said, are designed for outpatient and community-based settings. So they really focus on chronic challenges of caregiving without really including some of those acute needs that would be part of a care transition. And so our goal was to adapt this intervention to really make it relevant to the VA and hospital care, but also to modify the intervention to make it easier to implement in our clinical practice setting. So I'm going to share a couple of the kind of adaptations that we made. The first focused on improving services, access to home and community services. So the VA has a lot of home and community services available to all veterans with dementia. So this includes home health aides, respite care. And one of the things that we heard in our semi-structured interviews was that caregivers were not always aware that these services existed or how to access them. And so this led to the creation of a VA Care Transitions Handbook for caregivers of veterans living with dementia. And so as part of the intervention, caregivers receive a physical paper handbook in the hospital, and this handbook is a supplement to the online skills training for Game Plan for Care. And it really provides specific information about the VA services and how to access them. And the decision was made to have a physical handbook because we knew that access to the internet was a challenge for some caregivers. They don't all have access to devices. Internet is spotty within our hospital. And we wanted to give caregivers something that they could use immediately. And in our pilot, caregivers actually love this. They read it cover to cover while they're in the hospital. Another example of an adaptation that we made to the original intervention was to change the timing of when calls happen. So from the care transitions literature, we know that successful interventions to reduce post-discharge or improve post-discharge outcomes include early and frequent phone calls. And so we changed the timing of the calls to kind of match what is in that care transitions literature, where typically the first call happens within 48 to 72 hours, and then there are several calls within that 30-day period. So where are we now? We've completed the adaptation of Game Plan for Care, and we're doing testing it as a feasibility and acceptability pilot. For our pilot, we're focusing on understanding whether the adaptations that we made actually fit our context and support our ability to reach caregivers in the hospital. And the design outcomes that are going to come from this pilot will be used to make additional adaptations to support successful implementation in the future. And then the final part of my career development award will be doing a pilot randomized trial to evaluate this intervention in the hospital. So my last plug is that there are many, many caregiver support programs that are efficacious. There are a few that have been translated to regular kind of everyday care. And so many caregivers do not receive these evidence-based interventions. And so when we're considering behavioral health interventions for caregivers of adults living with dementia, I think we really need to think about adopting existing interventions to new contexts rather than creating new interventions. And so as interventions are adapted, it is critical that we use frameworks to fully describe the modifications that we make to the intervention and the rationale behind these modifications. Thank you.
Next speaker is Ms. Miriam Mojtabai from UT Health San Antonio.
Hi, my name is Mary Mojtabai. I'm a PhD candidate at UT Health Science Center in San Antonio, and I work in the Biggs Institute for Alzheimer's and Neurodegenerative Diseases in the Neuroimage Analytics Lab. Through our brain donation program, we have a unique opportunity to study neurodegenerative disease through postmortem imaging and also through histopathological analysis. Here, I will present the preliminary results from the manual segmentation of cerebral small vessel disease lesions, which will be used to train machine learning and deep learning models. Let's see, how does this work? Oops. I'm not sure if I pressed the... Got it, thank you. Cerebral small vessel disease, which is prevalent with age, is a medical condition that affects the small blood vessels in the brain and can often be caused by risk factors such as high blood pressure and diabetes. Vascular brain injury is also a prevalent finding, which manifests as lesions in the brain. Through in vivo imaging, we have learned about the appearance of these lesions, which results from this brain injury. White matter lesions, which are commonly referred to as white matter hyperintensities, as they appear hyperintense or bright on T2 MRI, are large and irregularly shaped lesions, and the borders can be somewhat undefined. And large perivascular spaces are small and usually numerous lesions, while infarctions are less numerous but also small and can be difficult to detect. Multiple MRI modalities are required to accurately detect these lesions, and they have different magnetic resonance properties, which is useful in differentiating the lesions from each other and from normal tissue. And we have developed a imaging protocol for ex vivo imaging to supplement the in vivo imaging. So the Biggs Brain Bank runs an active brain donation program that includes MRI and histopathological analysis. The brain, brainstem, and spinal cord are collected once consent is obtained. And we freeze the right hemisphere for future analysis and fix the left hemisphere in formalin for imaging. And after imaging, the brains are cut for the histopathological examination, and the slabs are shown in the right figure here. And the brains are left in the bags for approximately 2 weeks to reduce air bubbles that can be trapped in the ventricles and the sulci. And these air bubbles would cause artifacts in the MR imaging. So after this waiting period, we transport the brains to the scanner for imaging. We use an 8-channel knee coil because the smaller volume increases the signal to noise. Our MRI technician and radiologist ensures the quality control for each scan. The benefits of postmortem imaging over in vivo include longer scan times so that we can acquire high-quality scans and use a variety of MRI protocols during one scan. These protocols that we currently use include T1 and T2 weighted, fluid attenuated inversion recovery, diffusion weighted imaging, and susceptibility weighted imaging. And this imaging process is not feasible with in vivo scanning, as the patient and subject has a limited time that they can comfortably be in the scanner. So currently we have scanned over 200 brains with various clinically diagnosed neurodegenerative diseases. And after visual inspection, the 3 lesion types could be seen on the T1 and T2 weighted scans of the 80 diagnosed cases. And of these, we manually segmented the lesions of 38 cases. We use the segmentation tool ITK-SNAP, which allows us to draw the segmentation pixel by pixel and slice by slice, which results in a 3-dimensional segmentation that can be analyzed and used as a ground truth to train deep learning and machine learning models to apply to large cohorts. So as previously mentioned, white matter hyperintensities appear hyperintense on T2 MRI, which you can see on the right. But they appear hypo to iso-intense on T1 MRI, which makes them difficult to see with that modality. So it's important to include at least T2 scans to detect these lesions. And as you can see, they can be large and irregularly shaped, and the borders can be somewhat difficult to see, which makes manual segmentation time-consuming and difficult. So machine learning applications would speed up this process. In the same slice as we saw before, there's a infarction that's segmented in green. It's difficult to see, so there's zoomed in images. It's referenced by the green arrow. They are variably iso-intense on T1 and variably hyper-intense on T2, so multiple imaging modalities are required to detect these lesions. And the location in the brain can also vary, so visually detecting these lesions is very time-consuming, which is another reason why deep learning automated detection is very useful in detecting these. Enlarged perivascular spaces, which are shown in red, are hypo-intense on T1 and hyper-intense on T2, which is useful while detecting these lesions. They can be very numerous and found throughout the subcortical white matter, and their number and size makes them especially difficult to manually segment, especially in large cohorts like we have here. So neuroimaging is a powerful tool in evaluating CSVD, especially with MRI, as it provides really great soft tissue contrast and the ability to manipulate that contrast. Ex vivo MRI is especially advantageous because it allows for the longer time scans and higher quality images. And so in this study, we were able to quantify and assess the CSVD lesions to use to train models to automatically detect them. And some very exciting and novel future work includes MRI-guided histopathology. And this will allow us to directly relate the MR signal to the brain to biological markers. So to do this, we locate the lesions and use MRI landmarks to guide the cutting. Then these slices are stained and digitized with a high-resolution optical scanner. And we pick an ROI in the stain that corresponds to the region selected in the MRI, which is shown by the green dot. And then we segment the desired stain to measure the percent area stained within that ROI. And this is especially useful when analyzing small lesions such as EPVS and infarctions because they can be easily missed with standard cutting. But with MRI-guided cutting, we can ensure that they are actually stained. And for more information, you can see Lee et al.'s recent paper in the Journal of Alzheimer's Disease, which describes this postmortem project in detail. And I would like to thank my supervisor, Dr. Habez, my lab members in the Neuroimage Analytics Lab, and my co-authors for their contributions to this work.
Actually, we have time for one question. Yes? Questions? Thank you. So next speaker is Diana Salah from Texas A&M.
Hi everyone, I'm Diana Salha. I'm a research assistant at Olera as well as a student at Texas A&M University. And at Olera, our mission is to increase accessibility and affordability within the elder care ecosystem. So we know that affordable and accessible solutions is a very big challenge within elder care, but we've isolated 3 key pain points that really undergo this challenge. So the first one is navigation. It's very difficult to navigate this elder care ecosystem. The second one is finding affordable solutions. And the third one is individualized financial support. So current solutions are like Seniorly or Caring.com really provide a one-size-fits-all approach where they're just giving you educational resources, not actually guiding you to your personal case. And this was done through our preliminary work, which was funded through an SBIR Fast Track grant through the NIH. And so we conducted 2 studies. One was an interview study and one was a qualitative study where we looked at the financial and legal and functional challenges caregivers who were providing care for dementia and Alzheimer's patients were experiencing. And so looking into the interview study a little bit more, we created this diagram to really showcase how the system can be very overwhelming. In each of these 5 areas, there's subsets, and those subsets have their own complexities. So for somebody who's first time being a caregiver, looking at this and trying to understand all these different functionalities is very difficult, as well as there's no standard cost approach. So if you look at a home health facility a block down versus 2 miles away, they're gonna have different pricing points as well as quality. And further, through our interview study, I've provided a couple of quotes just really showcasing what we saw. You see words like overwhelming, unable to afford it, difficult to navigate, daunting, time-consuming. So from these findings, we went into our qualitative study where we were able to identify 5 key areas that caregivers need support the most in financially. And so this study was more to see, okay, taking these studies, how can we create a good initial prototype to start providing caregivers with the solution that they need? We did this through a build, measure, learn approach, where we built out our first initial prototype. We measured it through our usability study, and then we learned from those findings and iterated on that. And this is an approach that we constantly use to really perfect our solution. So this is what the initial prototype looks like, and you can feel free to scan the live version, which is currently available. Essentially, it's a care planning tool for personalized recommendations. So caregivers would go online, they would take a questionnaire, and then we would recommend, okay, here are the 3 things that you can look at for this specific home health facility. We give you the quality, this is the staff to care recipient ratio, this is the monthly price. So they don't have to go on the hunt to really find this information. And this is the findings that we had. We had very encouraging and positive results through our usability study. We had high scores in engagement, functionality, aesthetics, information quality, and many caregivers said that they would recommend this to another caregiver. But once again, going back to that build, measure, learn approach, we really want to perfect this solution. And one area for improvement that we saw was that there's a lack of individualization when it comes to levels of experience for the caregiver. Obviously, a caregiver who has only had this is their first time being a caregiver is going to be a very different situation than somebody who's maybe gone through this a couple of times. And the last thing on this slide is that we received a 4.57 out of 5 on our mobile application rating scale score, which once again shows high user satisfaction. So this is what our new prototype is aiming to be. It's an AI-powered Olera care planner. And so essentially what we do is we have a multi-agent network, and we use a large language model to really individualize this further. And so what we do is we have a needs assessment agent first, which really evaluates the financial condition the caregiver is currently in. We have a discounts data agent, which looks at, okay, what financial resources is this individual eligible for? And we have a payment strategy agent that just optimizes the payment strategy that the caregiver needs. And so the value that we bring to caregivers is really just alleviating this caregiver burden. We're automating this time-consuming process and really streamlining it for individuals. Additionally, there's currently $30 billion in unclaimed financial aid, and we really hope that through our agents, we'll be able to put this money back into caregiver pockets. And so this is our current traction and growth. With our initial prototype, we already have 250 caregivers using the service. We have over 30,000 service providers on the platform, creating a nationwide network, as well as increased our website traffic by over 30% each quarter. And once again, we received very high ratings on our usability testing. But beyond that, where we really want to go is to further develop this database of resources by increasing our provider network through for caregivers as well as for providers through website traffic and strategic partnerships, as well as our community building through our Healthy Aging community, which has already 11,000 individuals registered. And we have already begun, going back to that build, measure, learn approach. In a second usability study, we've begun recruitment for the newest prototype with over 300 families already recruited. And we want to build out the multi-agent network to really get the next prototype up and running. And this is our multifaceted team at Olera that's really dedicated to increasing affordability and accessibility within the elder care ecosystem. And that's it. Thank you so much.
We have time for questions. Yes?
So right now it's a free service, and we hope to keep it that way. We've been ideating through payment models of how we want to do it for providers. So for example, advertisements on the website, things of that sort. But we really want to keep it free for caregivers.
All right. Thank you. Okay, the last speaker of this Data Blitz session is Dr. Anna Fracassi from UTMB Galveston.
Hope you all can see me. And so good morning, everyone. Thank you for inviting me. And I'm Anna Fracassi. I'm an assistant professor at UTMB at Mitchell Center for Neurodegenerative Diseases. And today I'm going to talk to you about the role of microglia in cognitive resilience to Alzheimer's disease. And do you have this? Okay. So I know that you all are familiar with Alzheimer's disease, and you know that it's the most common form of dementia, and it is characterized by progressive neurodegeneration. From a microscopic point of view, Alzheimer's disease is characterized by the accumulation of A-beta plaques and neurofibrillary tangles. And the accumulation of these two hallmarks correlates with the severity of dementia. But this is not completely true, because the correlation between A beta plaques and tangles and dementia has been challenged by the emergence of a particular cohort of individuals that we call non-demented with Alzheimer's disease neuropathology, or NDAN. And these individuals, despite presenting A beta plaques and neurofibrillary tangles, they remain cognitively intact. So the existence of these individuals suggests that there are some unknown mechanisms in the human brain that are triggered to resist, to fight dementia. And understanding such mechanisms is really important because we can design therapeutic strategies centered on inducing resilience to anyone who is challenged with Alzheimer's neuropathology. We have been working with these individuals for the last 10, 15 years. Actually, Dr. Tagliatella is working with these individuals. And recently, we are focusing our attention on the role of microglia and neuroinflammation in cognitive resilience. And as you can see here in the image, we know that in a plaque environment, the accumulation of A beta plaques and of A beta oligomers and phospho-tau lead to the formation of dystrophic synapses. And it is known that the microglia is attracted to the plaque to remove these damaged synapses. And of course, depending on the efficiency of microglia in removing this damage, so the damage can be limited to the vicinity of the plaque or can spread along the axons and affect the neurons that are close by the plaques. So in this context, an important player is the phosphatidylserine. Phosphatidylserine has been recently demonstrated that the flipping of phosphatidylserine is a neuronal hit-miss signal for microglia that has to engulf the damaged synapses. And an important player in this repair mechanism is the surface receptor microglia called TREM2 that actually work as a docking protein between the damaged synapses and the microglia. So based on the scavenging role of microglia and TREM2 role in the scavenging function of microglia in the removal of damaged synapses, our hypothesis is that the efficient microglia phagocytosis of damaged synapses underlies synaptic resilience in these individuals, in these resilient individuals. We basically we performed a comparative study of post-mortem brain in AD, using AD and NDIN individuals. And as you can see here in the image, we stained for A beta plaques and IB1 and TREM2. And we found that actually these individuals have a higher TREM2 positive phagocytic microglia around A beta plaques, mostly related to their capacity, ability to engulf A beta and damaged synapses. And we confirm also the presence of these phagocytic microglia also using other markers like CD68. It is a marker for microglia lysosomes. And as you can see here, we have increased level of CD68. And I want to point the attention of the shape of microglia that we have close to the plaque. So it's really this amoeboid phagocytic shape that is typical of phagocytic microglia, an engulfing microglia. To test actually the efficiency of this microglia in removing the damaged synapses, we performed this set of experiments, and we stained for PSD95 as marker for synapses, and CD68 again, like for microglia lysosomes. And first of all, we saw that around plaques, NDIN individuals, the resilient individuals, had more synapses, more PSD95. But the most important thing was that we were able to find evidence of the engulfment of the damaged synapses by the microglia lysosomes. So as you can see here in the colocalization between the red dots and the green dots in yellow. As I mentioned before, a key player in this repair mechanism is the phosphatidylserine. And we wanted to analyze the levels of phosphatidylserine in our samples. And Dr. Marcatti isolated synaptosome from frontal cortex of these individuals. And we found, actually, surprisingly, we found that the highest level, the highest percentage of synaptosomes exposing phosphatidylserine were the NDIN individuals. So suggesting that the resilient individual are more prone to expose the damage that has to be recognized by the microglia. And we confirm this data by super resolution microscopy, as you can see here in the images. And we wanted to actually check the formation of this complex among the synapses, the damaged synapses, and TREM2. And as you can see here in the image, we found the highest level of colocalization between among these markers in NDIN individuals, suggesting that in the resilient individuals, the formation of this complex aim to remove the damaged synapses is more efficient in this individual as compared to AD and control individuals. We also conducted a study of synapses and dendrites and synapses, and we found very interesting data about that. And basically, we found healthy dendrites and synapses in these individuals. We are presenting a poster on this latest data, so I don't want to spoil anything. Please come to see our poster because it's really, really interesting. In conclusion, we can say that the NDIN individuals show higher TREM2 activation of phagocytic microglia as compared close to the plaque as compared to AD patients. And this hyperactive phagocytic microglia is the one involved in the engulfment of damaged synapses. And as we saw with the colocalization of the PSD95 and microglia lysosomes, these individuals are characterized by the presence of healthy synapses close to the plaque. And the NDIN may be hallmarked by a new type of disease-associated microglia, specifically localized near A-beta plaques and associated with the resilience. Of course, this is an ongoing project, specifically this part. And so maybe next year we will have new data about that. And of course, in the future, a treatment aimed at elevating TREM2 levels to enhance this efficacy of phagocytic microglia could be beneficial on inducing synaptic resilience to anyone who is challenged with AD pathology. With that, I would like to thank my mentor, Dr. Giulio Tagliatella, and all the members of the Dr. Giulio Tagliatella's lab, the Alzheimer Association and NIH for funding our projects, and of course you for your attention. Thank you.
Okay, so with that, we close this data blitz session. So we now have a break, and then I'll see you in the Oscar Fisher lecture. Thank you.
We will now take a short break and meet for the keynote address in Grand Salon C at noon.